Hello mathematicians, this is the notes video for chapter 3 lesson 8 and our learning target is I can solve systems of equations algebraically. So the cool thing about today's lesson is that all of those equations that we took a couple months to solve back in November, December, and January, they are coming back into play today. So you'll get to use all of those skills that you used back in chapter 2 today in the end of chapter 3. So solve systems algebraically. In previous lessons, you established the solution of a system of equations by graphing. Substitution is an algebraic model that can be used to find the exact solution of a system of equations. So instead of solving by graphing, we can solve algebraically using substitution. So number 1, it says solve the system of equations algebraically. Y equals x minus 3 and y equals 2x. So since y is equal to 2x, you can replace y with 2x in the first equation. So for example, you can substitute in 2x for y. So 2x equals x minus 3. Subtract x from both sides of the equation to get x by itself. And we end up with x equals negative 3. So since x equals negative 3 and y equals 2x, then y equals negative 6 when x equals negative 3. The solution of this system of equations is negative 3, negative 6. So then you can also graph the equation or graph the solution as well. Let's try A and B. So we're going to solve each system of equations algebraically. So for letter A, we'll start with substituting in 2 for y. So y equals x plus 4, and instead of the y here, we can substitute in our 2. 2 equals x plus 4. Subtract 4 from both sides. So x equals negative 2. Now I can substitute in x for the equation. So y equals negative 2 plus 4. So when x is negative 2, y is 2. So then the ordered pair for this system of equations would be negative 2, 2. And so that would be the ordered pair and the answer for A. Negative 2, 2. Okay, let's solve B. So we'll substitute in 3x for y, since I know that 3x equals y for the second equation. So y equals x minus 6. Substitute in the 3x for y. 3x equals x minus 6. Subtract x from both sides of the equation. And we're left with 2x on the left and negative 6 on the right. Then I can divide by 2 on both sides to get x by itself. 2x divided by 2 is just x, and negative 6 divided by 2 is negative 3. Now I can substitute in my negative 3 into the equation. Y equals 3x. Substitute in negative 3 for x. Y equals 3 times negative 3. 3 times negative 3 is negative 9. So when x is negative 3, y equals negative 9. So my ordered pair for that system is negative 3, negative 9. All right, slope, intercept, and standard forms. Sometimes one or both equations are written in standard form. When solving a system by substitution, one of the equations should be solved for either x or y. So notice that in slope-intercept form, we have the equation solved for y, and in standard form, you can turn that into a slope-intercept form equation and either solve for x or y. Example 2 says solve the system of equations algebraically, and we're given a slope-intercept form equation, y equals 3x plus 8, and a standard form equation, 8x plus 4y equals 12. So 8x plus 4y equals 12, and so we can substitute in 3x plus 8 for y into the standard form equation. When we do that, we can use the distributive property and multiply 4 times 3x and 4 times 8. So we're left with 8x plus 4 times 3x plus 4 times 8 equals 12. That simplifies to 8x plus 12x plus 32 equals 12. Then we are combining like terms, so you're combining the 8x and the 12x to make 20x, and we're left with 32 equals 12. Subtract 32 on both sides, and we get 20x equals negative 20. Divide by 20 on both sides, and we find that x equals negative 1. Then you have to substitute the negative 1 back into the slope-intercept form equation. So y equals 3x plus 8, substitute in a negative 1 for x there. Y equals 3 times negative 1 plus 8. And so you'll get an answer of positive 5. So when x is negative 1, y is 5. So our solution to that system is negative 1, 5. Okay, let's try that on our own now. Okay, for the first set of equations, we have y equals 2x plus 1. So I'm going to substitute in 2x plus 1 for y into this equation. So I'm going to use a different color, and it'll be 3x plus 4 times 2x plus 1 equals 26. Okay, so we have to use the distributive property, 3 times 2x and 4 times 1. So it's 3x plus 4 times 2x, which is 8x, times 4, or plus 4 times 1, which is 4, equals 26. Then let's combine like terms. 3x and 8x both share a common variable. 3x plus 8x is 11x, plus 4 equals 26. Subtract 4 from both sides of the equation. We have 11x equals 26 minus 4, which is 22. Divide both sides by 11. 11x divided by 11 is just x. 22 divided by 11 is just 2. So we have x equals 2. Now we have to put that back in to this equation. Y equals 2x plus 1. Substitute in a 2 for that x. So y equals 2 times 2 plus 1. Y equals 5. So when x equals 2, y equals 5. So my ordered pair answer for this problem is 2, 5. And I can write that on my line above, 2, 5. Okay, now let's try the next set of equations. We have 2x plus 5y equals 44, and y equals 6x minus 4. So since the second equation is already solved for y, I'm going to substitute in 6x minus 4 in for y into the first equation. So 2x plus 5 times 6x minus 4 equals 44. All right, so we have to use the distributive property. 5 times 6x is 30x, and 5 times negative 4 is negative 20. Don't forget about the 2x at the beginning. So combine like terms. 2x and 30x have the similar terms. So it's 32x minus 20 equals 44. Add 20 to both sides to get 32x by itself. and this becomes 0, so we have 32x equals 44 plus 20, which is 64. Divide both sides by 32. 32x divided by 32 is just x. 64 divided by 32 is 2. So when x equals 2, we have to figure out what y is. So substitute in 2 for x into the y equals 6x minus 4 equation. So y equals 6 times 2 minus 4. 6 times 2 is 12 minus 4. I know that y equals 12 minus 4, which is 8. So when y equals 8, x is 2. So my ordered pair answer for this set of equations is 2, 8. Okay, example 3. A total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. Write a system of equations to represent this situation. Draw a bar diagram, then write the system. So the bar diagram below shows that there's 4 times more cookies than cakes. X will represent the number of cakes and Y will represent the amount of cookies. In total, there are 75. So y equals 4x and x plus y equals 75. So our job is done because all we had to do was write a system of equations to represent the situation. Number 4 says solve the system in example 3 algebraically and interpret the solution. So since y is equal to 4x, you can replace y with 4x. So x plus y equals 75, replace the y with 4x, which turns into x plus 4x equals 75. Combine like terms. X plus 4x is 5x. 5x equals 75. Divide by 5 on both sides of the equation to see that x equals 15. So since x equals 15 and y equals 4x, then y equals 60 because you substitute in 15 for x. So when x equals 15, so the solution is 15, 60. This means that 15 cakes and 60 cookies were donated. All right, let's try E and F. Mr. Thomas cooked 45 hamburgers and hot dogs at a cookout. He cooked twice as many hot dogs as hamburgers. So the first thing I'm going to do is draw a picture. So I know that there are 45 in total. Okay, and then we'll have this be the hamburgers. And I know that there's twice as many hot dogs. So this is HD. And then we've got HB for burgers. Okay, so this will be my x and this will be my y. So I know that x plus y equals 45. And I also know that 2x equals 1y. So I can substitute 2x in for this equation for y. So x plus 2x equals 45. So it's 3x equals 45. Divide by 3 on both sides of the equation. To get x by itself, 45 divided by 3 is 15. So I know that the number of burgers is 15. So it'll be 15 here. And then now I need to solve for y. So you can substitute in a 15 for x here. So 2 times 15 is 30. So y must equal 30. Okay, so you wrote and solved system of equations there.